Hel- Hello, everyone. Okay,
Hey.
welcome at the Rootlabs. And today we're going to talk about Azure, Azure Machine Learning, so a managed service within Azure. And the two colleagues of mine that will help us with that are none other than D. Jill Henry and D. Joris Schouwen. So just to give like a short introduction, Joris is a machine learning engineer at Data Roots, and Gilles is a senior Datazilla at Data Roots. They have extensive experience within Azure and Azure machine learning in special. They have used it on client sides as well. And now we're ready for liftoff. So I'll shut up and I'll pass the word to Gilles and Joris.
Thanks for shutting up, Dorian. It's really kind of you.
You're welcome.
All right. I guess you can see my screen, right?
I'll still need to edit the stream. Okay.
Sorry?
Here it is.
All right. Okay, cool. Okay, thank you, Dorian. Well, let's get straight. Ooh. Well, that's my phone. Sup. So, Joris, I heard getting models, machine learning models in production was quite challenging.
Oh yeah, definitely. And that's why many companies and organizations have put a lot of effort into developing platforms to make this process a bit easier.
Yeah, indeed. Here we're showing some of these platforms like MLflow, Deploy.ai, but today we'll be mostly interested in Azure, the machine learning service provided by Microsoft. So let's have a look. All right. Joris, could you tell us what the actual goal is of machine learning, of Azure machine learning? Like, how does Microsoft promote this service?
Well, according to Microsoft themselves, the Azure Machine Learning Service empowers developers and data scientists with a wide range of productive experiences for building, training, and deploying machine learning models faster. So they really want to accelerate their time to market and foster team collaboration with industry-leading MLOps. This is DevOps for machine learning. They want customers to innovate on a secure, trusted platform designed for responsible machine learning.
All right. And if you have a look at this diagram, we can see that they provide some of these features like scalable on-demand compute or data storage and connectivity, some orchestration tools for your machine learning workflows, the ability to manage and register your models, but also to track them, so checking their performance, monitoring them. And of course, at the end, you always want to deploy these models. But all of these functions or this functionality is relying on the Microsoft Azure infrastructure. Should we understand this as some sort of lock-in?
Yeah, so indeed you get a lot of these cool features and it comes at the price of this lock-in and you do not control everything.
Okay, but how do these features get implemented? Like, what are the underlying resources that Microsoft Azure is using?
So in Azure, if you want to do really anything, you should first create a resource group that will structure all your resources together. And then you can create a machine learning workspace inside this resource group. The workspace cannot just function on its own. You need a bunch of other resources on the right here, like a storage account, application insights, etc. If you're not very familiar with Azure, we'll quickly go through these. I'll explain them briefly. So the storage account, the name is, well, says it all. This is where you store your data. Think blobs, files, queues, tables, and disks. Then we have the application insights. This is what you use to monitor your live applications. Then we have the key vault. There you can store your secrets and keys so they don't leak out to the public. You have virtual machines, which is one of several types of on-demand scalable computing resources that Azure offers. And last but not least, you have the container registry that you can use to store, build, and manage container images and artifacts in a private registry for all types of container deployments. So if you have all of these resources, you can really start working in your machine learning workspace. And there you can really get some more machine learning specific resources like compute clusters, notebooks, pipelines, etc.
All right, that's pretty cool. What I really like is the fact that they are integrating so well with other services that they have been testing and using for so many years already, like the storage account. But I was also thinking about the key vault when it comes to security. This brings a lot of security to the workspace too. So that's pretty cool.
Yeah, this really makes Azure ML a quite mature and robust platform.
Mm-hmm. But now, as an end user, like how can we interact with the platform itself?
So there's multiple ways to do this. There's the CLI, you have GUI, SDKs, and you can even do some infra as code, think Terraform. So they all have their pros and cons. For instance, the GUI is great to quickly see what's possible inside the machine learning workspace. You can get some more intuition there. You can even train some models without actually writing any code at all. But the functionality is not as great as with the SDK or the CLI. There you can really customize almost everything you want to do.
Yeah, that makes sense, Joris. That makes sense. But perhaps we could show all of these right now. No, we could maybe run a demo.
That's a great idea. So I know it's going to sound crazy, Gilles, but imagine you are a senior machine learning engineer at DataRoots and you want to develop a model that needs to get into production.
Yeah, that sounds a bit crazy and quite challenging too.
Oh yeah. So now imagine we have this New York City taxi dataset containing information about taxi trips, for example, the number of miles, the number of passengers, etc., but also the total amount customers had to pay for their trip. Let's try to put a model into production that can predict how much you would need to pay upfront.
All right, sounds good. But I guess first I want to have a look at the data itself and maybe do some exploration. So maybe I can use the Azure Machine Learning notebooks.
Yeah, that's a good idea. But first, you'll need a machine learning workspace.
Well, very fortunately, we already built one. So let's go to the workspace. Here's my workspace. It's been built through Terraform. And as you can see, we have these other services that are linked to the machine learning workspace. So we have the storage account here. We have the container registry, the key vault, the application insights. And so now, well, we can have a look at the actual GUI that Joris mentioned. So let's go to the homepage of the service. So here, I'm on the homepage of Azure Machine Learning in this specific workspace. You can already see a few things like some runs that we had with some pipelines. We can see some compute resources that we created. And we can also see some sub-services or these features that we mentioned, like the pipelines, the models, etc. But now we're really interested in the actual notebooks because we want to explore the data. So if I click here on notebooks, I get straight to a notebook that we uploaded, and we can already see the default interface that Azure ML is providing for us. So here we could have a look at the code that explores the data, but maybe this interface is not the one you want to use because you're more used to something else like Jupyter Lab, for instance. And fortunately, that's possible too. As you can see, this notebook is already attached to a compute engine, and it's also linked to a storage account, actually. So here, if I go to the storage account that's linked to my machine learning workspace, I can also find this notebook. So this is the storage account here that we have. And here I'm in a file share system, and I have these temporary files, but also the notebooks that's attached currently to this compute instance. So how did we create this compute instance? Well, we can have a look here at the compute instances. It's here And we can see a few things like what kind of machine it is, when it was created, last Friday apparently, and also some URIs that we can use to access this compute. Now, we created this compute instance through a CLI. And here's the command that we use. So you see it's quite simple. It's really easy. You just need the right permissions to do it. Provide, as we said, what kind of machine you want to use. So this means if I have a notebook and I want to use some GPUs, I could also do it. So it's really flexible. It allows us to do many things. But now let's say, okay, I want to explore this data, but I want to do it through Jupyter Lab. So I could click here, and this would, well, link me to this address here. And we can have indeed a look at the data set. Here we see the taxi trips, some information about the trip distance, and some other stuff too. But here the purpose is not really to look too much into the details of this data. So now, Joris, I have my notebook. I have explored the data. What should I do?
So after you've explored your data, you should have quite an understanding of what it looks like and what you want to achieve out of it. So it's the right time to have a look at the pipelines where we could do some data preparation and try to build some models.
All right, sounds good, sounds good. So let's go to the pipelines. Here, I'm on the pipelines section. I already see we had one run with some pipeline. And this run was actually triggered with this pipeline endpoint. So here, this taxi pipeline is actually the pipeline that we built. But to get a better understanding of these pipelines, maybe I can take you guys first to the Azure Designer here. So the Designer is some sort of graphical interface that you can use. You can do some drag and drop to create these pipelines. So if you're not really, experimented with coding, etc., it could be a way to approach machine learning problems. So here, let's have a look at the pipeline that we have that was designed with the Azure ML Designer. So this pipeline, as you can see, is a regression pipeline predicting automobile prices. So let's have a look. Here, it's really visual. We can see the different steps that are quite typical of these machine learning workflows, like getting the data, selecting a few columns, maybe doing some cleaning, splitting the data. And then, of course, there is the part where you want to train an actual model. And at the end, we'll evaluate this model. So if I'm an end user and I'm thinking, yeah, linear regression is not my favorite algorithm for some reason, I could definitely use another one. Like here, I could use decision forest regression, and I could simply drag and drop it, and connect it. So that's quite easy. But of course, we have less flexibility, less control over what's implemented here.
So this looks cool, Gilles, but what if you want to do something more custom?
Yeah, well, then we definitely should have a look at the pipeline that we created for the taxi. All right. So here, this is the pipeline itself. You see, it's quite simple. We only have 2 steps. We have a step where we prepare some data. So we prepare the taxi data, actually. And then we have a step where we build the model with the data that's been prepared. And so here, we're using this output-input mechanism to provide the data set from the first step to the second step. As you can see, we also provided some constraint in the way these steps are run. So first we need to run this step, of course, and then we can run this step. But here I'm on the UI, and I can already see a few things about these pipelines. But what's really great is when you have an actual run. So here, let's go to some run that completed. All right, I get to this part of the UI. And here I can get a ton of information about the steps, the run, but also the pipeline. For instance, I can get some info about the logs. I can see some metrics. I can see some snapshots, so meaning what were the files that were uploaded to this pipeline so that it could actually run. So you can think about Python scripts, etc. And then if you click on one step, you can have some information at the step level. So here, by default, if the pipeline has finished running, I'll be taken to the driver log, where I'm getting, well, the application's logs, basically. Like here, for instance, we can see that we're reading some data from some place. Here, it's really the New York City taxi data set. But I can also get some extra information about the way the environment was built. So the way this works is the pipeline gets attached to some compute instance, and this compute instance, like a virtual machine, will be hosting some Docker container, and this Docker container needs to be built. And so this is the information you can see in the image build. And once that container is built, well, it's just gonna run these Python scripts through Conda. So it's using Conda within Docker, within the virtual machine, and there you can really do whatever you want, you know. So it's pretty customizable. But maybe, Joris, I can show you the code that we wrote to create this pipeline. So with the SDK calls, etc.
Yeah, that sounds very good.
Okay. So here it is. That's our pipeline. I'll take you here when we get the workspace.
Okay, so actually building its pipeline using the SDK is quite straightforward. It all starts with the workspace, which is really kind of your entry point using the SDK. You just specify the name of it, your subscription ID, a resource group where it's in, and then you get it. So the first thing you need for a pipeline is, well, it's going to run on some compute instance or some Kubernetes cluster. So you'll need to specify what libraries you're going to use, which you can easily do with this Conda dependencies object. It's nothing more than just a YAML file containing whatever you want to use. And then once you have this, you put it into a run configuration. This run configuration will then be passed later on when we create our actual steps. So the next thing you need to do is to specify, well, where do you want to run your pipeline on? So a CPU cluster in our case. We have some custom logic in place to create it. Maybe it's worth to check it out to see how easy.
Sure.
Yeah.
Let's go.
So here we first check whether our workspace already has a cluster with the name we specified, and if it does, we can just grab that one. If it doesn't, we just create one with this line AML compute provisioning configuration. There we just specify what size we want. So if you check the documentation by Azure, you'll find a bunch of different types that they want to provide. This is a pretty standard one, but you can also get some GPU, you can get more heavy duty machines as well. And then what's really cool is also this max and min nodes. Here we've set both of them to 1 because we want our instance to always be running. But imagine you only want to pay for when you're actually doing stuff. You could put min nodes to 0 and it will also auto scale down.
Cool.
And yeah, the max nodes, of course, you can put it a lot higher if you want to. So that's that part. It's really customizable exactly to what you want in your pipeline. So once you have your compute cluster, you have to put some configuration about what kind of data store you need to use. You can put some source directory where your scripts will be in your own file system. And then you're ready to create your first steps. So here we have provided 2 steps. The first one will just clean and prepare the data a bit. And then in the second step, we'll be doing some multi-step modeling. So it's really easy. You just specify the name of this script. Here we, for some reason, chose the directory where it's at to easily find it again. But that's not needed because to actually point to the script, you have this source directory. So then you specify the compute target that we just created. You give it the run configuration, which will hold your dependencies. Then you can specify some parameters. Here we just have some, here we have our subscription ID for demo purposes, because yeah, we're not really using any parameters. But imagine you have a pipeline running for different parts of your organization. For example, you're an international organization and you want to run for different countries. For example, that could go here. And then you can also specify some inputs and outputs that will be used between the different steps. So we could specify, okay, step 1 outputs this, and then step 2 can use it. So it's really customizable this way. So once you have your steps, you can put them into a sequence with this easy step sequence object. Here we're just going to run them one after the other. But imagine you have a third step that doesn't rely on anything that step 2 does, then you could just put them in parallel as well. So after you have your step sequence, you just create the pipeline by specifying the workspace and your step sequence. And then you can publish it where you give it a name, you can give it a description if you want, and a version. And that's all there is to it.
Okay. That's really cool. So you can do tons of stuff, customize it the way you want, and it's really scalable since you can provide any compute target that you want.
Yeah, indeed. Cool. And so the next step, what do you think it is?
Well, you know, if I look at my pipeline, I'm preparing the data and I'm building a model. So I'm thinking, well, let's use that model, right? Let's deploy it.
Yeah, that's a great idea.
Good. All right. Well, here we can go to this step actually is publishing this model. So it's here in the models part where you can really track all your models if you want to. You can have different versions, etc. You can link the models and their versions to the runs that were submitted with Azure Machine Learning. And so here we have one model, taxi model V0. And the thing that we see here is the run ID. And something that's a bit strange about this run ID, but there is a good explanation, is this auto ML part. And actually, when we built the model in the second step of our pipeline, we call this service here automated machine learning. So let's have a quick look at this automated machine learning. So what is it? Well, you can find the explanation right here, but basically it's Azure ML that's going to build a lot of models for the experiment that you define. So here it's a taxi data set that we're providing, and it's just a regression task that we need to do. And this automated machine learning is going to try tons of models. So if we have a look at the run itself, we can find, of course, as always, the logs. The logs, the outputs. But here we can even see some information about the models it tried to build. So it tried a few models, as we can see, and at the end, apparently, the voting ensemble was the better model with that score here. So of course, it's very customizable. You can decide that you want to use another metric. That's totally fine. And at the end, you get a model. You didn't do anything. You didn't code anything. You just had to configure this automated machine learning run. And yeah, so it's pretty powerful. It's pretty powerful. But okay, I have my model here, and now I'd like to deploy it. I could do the deployment through code, but here I'm going to show how to do it through the UI, which is really easy. So you just click on deploy. And then you need to provide a few things, like a name for the model, maybe some description about the model. Then, very important, where you want to publish this model. Do you want to put it in Azure Kubernetes service, or do you want to use Azure Container Instance? That's up to you. You can provide a compute name. And then there is just two things that are still missing, is the entry script file. So the entry script file is going to be the logic on about how to use your model. So how you load it and how you can call it, making the predictions basically. So there you could also include some extra pre-processing. That's up to you. It's just an API at the end. And once you have this tree script, you can also, well, you need to provide the conda dependencies files. So again, it's using under the hood, it's using Docker, it's building these images to host your model, and it needs to know for conda, so for Python, what libraries are needed, etc. So that's it. Imagine we deploy this, it's already been done. To avoid any friction, so I can go to my endpoints where I'll see all the models that are, well, that have been deployed. So here we have it. That's our model, that's our deployment. And as you can see, we decided to deploy it on Azure container instances. So if I have a look at this model here, this deployment, I get some information. I can see that the deployment state is healthy, so that's good news for the demo. And we have the model ID, so we can really link it to the model that's being used here. But what we are mostly interested in is the REST endpoint. So we get this REST endpoint, and it means I can actually query this model. So now we're going to try to query this model together. Whoop. But, yep. So here I have a short script that's calling this model. It's simply sending a post request, as you can see, with 2 data points. And these 2 data points have some features about the taxi trip itself, like the vendor ID, the number of passengers, and the distance. So the main difference between these 2 data points here is the trip distance, according to me, but maybe the model will see other things too. As you can see, the trip distance is almost 10 times higher more than 10 times higher for the second trip. So we expect it to be a bit more expensive. That would be good for the taxi driver. So let's call this API, and we get an answer from the API. As we can see, the first trip would cost around $8 and the second one around $43. So that's it, Joris. You have your taxi prediction model in production, and it seems to be working.
Amazing. That looked quite easy. And so here we use Azure container instances for deployment, but I also saw the Kubernetes option. So I guess that's something we could easily change as well.
Yeah, totally. So if you want to use Kubernetes, it's feasible. It's like completely doable. But then you need to manage this Kubernetes cluster too.
Of course.
Okay, but cool, Joris. I feel like we learned quite a few things today. Well, I hope so. So maybe let's go back to the presentation. All right. And perhaps we can share some extra thoughts with the audience about our experience with Azure ML.
Yeah, great idea.
All right. So Joris, my first question is, we saw lots of great features, scalability, etc. But how do you feel about the lock-in?
Well, it's definitely there. But you can limit it a little bit in development by, for example, using Docker, so you can keep a lot of flexibility there. It is true, though, that you're completely relying on Azure. So if there is a blackout, yeah, this can be an issue. We have experienced this ourselves already. And yeah, sometimes there's just some problem with the backend, which is out of your control. And then you can just file some support requests. They'll be very friendly and try to help you. But yeah, this can be an issue.
Yeah, I see. But I guess it's the price we're ready to pay if we want to get access to all these cool features, right? And to these components that we saw. Plus, these components seem to be in active development.
Yeah, indeed. For example, they're still working on automatic retriggering of failed jobs. And we really see that Microsoft is investing big time. Their SDKs are updated almost every 2 weeks. So yeah, there's really a lot going on. And sometimes this can lead to some compatibility issues because there are different SDKs, pin versions of each other, and they might conflict here or there. So yeah, I advise to really look into this and pin the versions you need if you don't want unexpected things to happen. Another great thing is the usability. they really target multiple kinds of users with this. For example, through the GUI, it's really intuitive, and without writing a single line of code, you can actually get some machine learning models that are quite good baselines, to be honest. And then, yeah, some features are only available through the CLI or the SDK, but that's to be expected.
Yeah, totally agree with you. Something that I really like is the empowerment it provides to the end users with the infrastructure and its flexibility. So you can really get a lot of scalability, a lot of options, like GPUs, whatever makes sense for your project. So that's really cool. But how do you feel about the learning curve in general?
I think it's quite okay, but yeah, in the beginning you have to get used to Azure a little bit. You have to familiarize yourself with the SDK and all the different services and components they provide, to get an intuition of what you can do, what you cannot do, and how you should structure things. Because they are developing this actively, their documentation is not always completely up to date. So if you're following some quick start or something else, trying to follow along with some code snippets, it can be a little bit confusing. Some objects might be appearing out of nowhere, and if you don't know what they are, or if you haven't written any code using the SDKs yet, yeah, it'll take you some time to find what this is and how you should get these objects. Yeah.
I see. Okay. But cool, Joris. It was really cool discussing this topic with you today. But maybe the audience has got some extra questions for us too. So if you have a question, now's the time to raise it, or you can always contact us after this.
There are already some questions in the chat.
Okay. Well, can I see the chat? I don't think so, but
okay, I can read it for you. One question is, does it produce the Swagger docs automatically also?
No. You need to provide it, and but you can specify it and define it, and then it'll be accessible as you saw on the UI. You'll get a URL, and there will be automatically built for you. Yeah.
Okay. Another question that we had is, did you try using Azure Machine Learning via R instead of Python? And what was your feedback?
Well, we haven't tried it ourselves, and to be honest, I don't know if it's possible. I don't know, but we haven't tried it. But with Python, it's working great.
Yeah, I think it is possible to also do it with R, but yeah.
I do find some things with R for the SDKs, but yeah, okay. We haven't tried it, so.
All right.
Okay. I had actually some questions myself. What's your experience with AutoML? Does it outperform you with your manual model building?
Well, AutoML is really great to get some baseline. As you saw, it allows you to get many models tested out for you quickly, and usually the performance is quite good. But then, of course, you lose some control over what's being done, and there are still some things that where you as a data scientist or machine learning engineer will provide definitely more value than whatever is automated. Think of like feature engineering, data preparation, etc. Now, another thing is AutoML has got some constraints, like, well, the time required to just launch the cluster, etc., or to launch the run to build the environment. It's going to take some of your time. So meaning if you want to iterate quickly, in some cases, you'll be better off building a simple model, but otherwise, yeah, we use it a lot, and we like it. Yeah.
Okay. And speaking of feature engineering and data preparation, how tightly does Azure ML integrate with other data cleaning services?
Well, Azure ML already has got some functionality to do this. Like one part that we didn't cover too much is the data sets and data stores. And there you can register your data sources. It can be SQL, it can be some blob files, or like the equivalent would be S3 storage on Amazon. And there, Azure ML is gonna look, well, it's gonna allow you to explore the data, that's one thing, but it's also gonna keep track of the drift that can happen in your data. So for example, if you're doing some predictions with humans, and you've got some women, you've got some men, imagine at first you have 50% of each category, but then, I don't know, in 2 months you have 70 and 30. You can get some automatic alerts from Azure ML. So that's already one thing that's pretty cool. Even in your model performance, it's also doing this. But then when it comes to like data preparation and feature engineering, it also has some functionality. We saw in the designer, there is all these steps that you can drag and drop, and some of them can do this data preparation. But you need to know that, of course, if it's doable in the designer, it means there is some SDK that reflects this this functionality, and so you can also have it within your code. So yeah, it's quite overall it's doing well. It allows you to do quite many things. Yes.
Yeah. Okay, that's pretty cool. We have more questions in the chat.
Mm-hmm.
Another one is, what's your opinion about Azure ML vs Databricks? And what is, you think, the best option to develop and deploy models?
Huh. Well, that's a good question. Well, I guess Databricks is really oriented towards Spark and big data jobs, which you can totally do with Azure ML too. But depending on your experience, you might want to use one or another. Something that, that's my personal opinion, that I don't like that much is using or relying too much on notebooks. So I've seen this quite a few times where companies were relying on these notebooks and they were triggered and scheduled, and that was fine. But just for the the updates, the management, imagine working with Git, there it can get a bit messy. So that's one thing. But yeah, I think they're both great tools, so it's hard to just compare them like this. Yeah, I hope that's an okay answer. And on Databricks, you can use Scala too, which is fun. But
okay. How does the Azure machine learning stack relate to machine learning flow, ML flow?
Again, here, it really depends on your setup. You could ask the same question, how does Azure machine learning compare with like whatever Google has, whatever Amazon has? But then I think my answer would be, well, if you're already relying on some Azure services, for instance, if you have a data lake that's been built on Azure, well, then I would strongly advise you to use Azure ML, because they have all these connectors that are really well done for other Azure services. So it's going to be integrated really well. So that's my point of view. But I think Amazon and GCP are also doing great stuff. But it just depends on what your current setup is, what other services or cloud provider you are using, and that's it. So with ML Flow, it's kind of the same story. It's if you're already it depends on your infrastructure.
Yes, exactly. How would you do the performance monitoring in Azure ML of your models running in production?
So this is going to be case by case. We already mentioned the drift that was being done by Azure ML. So there you have quite a few options. It really depends on the use case. Yeah.
You can maybe define your own options as well then.
Yeah, totally. So as we saw for instance, in Azure AutoML, we could choose different metrics, like the optimization metric that we had, or the performance metric that we had was like the correlation. But there, if you want to track some other metrics, it's totally doable. So yeah, it can be really customized to your needs actually. Yeah.
Okay. Yeah, we have quite a lot of questions, so more questions are coming in for you guys. What's your experience with Azure Standard Compute instances? I often feel they underperform, even though the specifications actually look good.
I think for us, we don't really notice it underperforming. Maybe one thing is they always seem to take quite a lot of time to start. But other than that, I don't think we have noticed anything else.
No, indeed.
All right.
So, and with quite a lot of time, yeah, it's like maybe 8 to 10 minutes before your pipeline is actually running.
Yeah, but this can depend also on your location, on the demand at that time. If many people are requesting that kind of machine, then yeah, you might need to wait a bit longer. Yeah.
How many models do you currently have in production in Azure ML? Is Azure ML your preferred method to deploy models?
Well, it depends on, so here I'm speaking more at data roots level, I guess, but it depends on our customers. So not every customer is, is working with Azure. So it's not our preferred method. But if a customer is using Azure, then it's definitely a method that will be investigated. But it's really case by case. But here I can say, for instance, at one of our customers, we have like 50, maybe more than 50 models running in production, and they're doing just fine because of the scalability. It's like scalability is really not an issue with Azure ML, that's for sure.
Okay, of course, if you have enough money, yeah.
Yeah. Yeah, that's a good point.
And also, the people are interested in how you tackle the CICD pipelines.
Yeah, so this again depends on your setup. Your well, for instance, at the customer I was referring to with these 50 models, we're using Azure DevOps, which is also another service by Azure, and there we have these CICD pipelines where we can deploy these models in multiple environments like dev, staging, prod. And so that's how we take care of the CI/CD through Azure DevOps, yeah, and multiple environments. Yeah.
Mm-hmm. Well, something we didn't show as well is that you can really schedule these pipelines using the SDK. So, for example, you can have a run every week, and then if a new version comes up, what we tend to do is just deactivate the schedule and delete the current pipeline and just deploy a new one. Yeah.
Okay, so there's the flexibility for ad hoc API requests or either scheduled pipeline runs.
Yeah, totally.
Except for the lock-in, what are other possible downsides you've encountered to using Azure ML compared to AWS, GCP?
That's a good question. It's a good question. Well, I guess it'll depend on end user to end user. But one of the things I thought was sometimes hard with Azure ML is the way they're managing their dependencies. For instance, for AutoML, there it's got some requirements. So if you want to use AutoML, you'll have requirements on the dependencies you're using. And this can be sometimes problematic. Imagine you've had a project running in the past and it wasn't using Azure ML at all, and you were using some Python versions for different libraries. Well, there you might get some conflicts. So migrating to AutoML or Azure ML might be a bit painful. So that's one thing. And then, as Joris said, but this happens also with the other cloud providers. Sometimes, you know, some of their services or their backends are facing issues. And so you can have some errors arising in your pipelines, in your models, but it's not your fault. It's Azure's fault. But this is the same with other cloud providers. So it just depends on the SLA you want to get. This might be a factor worth considering too.
All right. How well does it perform with bigger data sets, Azure ML?
Well, very well. You know, like since you can scale your machines like vertically and horizontally. Well, you know, it's just scales, so it's doing well. Yeah.
Do you segregate your dev ACK prod into different EMLS workspaces?
Yes.
Yeah.
Yes.
I don't know what is EMLS.
Probably Azure Machine Learning. Yeah.
Okay. All right.
Yeah. Yeah. Totally. That's something we do, and we recommend doing it. Yeah.
Okay. Thank you everyone for the questions. Oh, there is one additionally. Is Azure compatible with all the different browsers, environments, and operating systems, or does it make you some problems if you're not working with Microsoft?
Oh, well, like browsers, I haven't tested them all, you know, so I don't know, but it's working fine with Google Chrome. It's working fine with, yeah, like Chromium-based browsers. But maybe, Joris, you tried other browsers?
No, I'm also a Chrome user.
Yeah, I think it also works fine with Firefox. But to be honest, I haven't tried it with Microsoft Edge or Internet Explorer. But yeah, I don't know. Maybe it works. You know, it's if you're willing to take that risk, you can do it. But I haven't tried, so I don't know.
How do you handle the complexity of your models in prod? Black box. Wait, the question is a bit hard to read.
Oh, you need some.
How do you handle the black box performance of your models in prod?
How do you monitor the?
Maybe it's a question about explainability.
Maybe. So when it comes to explainability, there are some. Well, Azure is already providing some information. Like you can see some information about the feature importances, and well, basically the feature importances. That's already a big one. And also it keeps tracks of the metrics, etc. You can have some global interpretation and some local interpretation too. But then, to be honest, I'm not sure what underlying libraries they're using it to provide these explanations. But you can also have your own libraries, like these models that you build. They can be serializable, so you can totally like download them and have a look at their local explainability or even their global explainability. That's totally feasible too. But when it comes to the black box thing, yeah, then it's going to depend on the use case that you have. Like if you want to have a very explainable model, well, maybe you won't use AutoML for that part, or you'll have to restrict the algorithms that AutoML can use. That's also something you can do. For instance, if you want to use only deep learning models, you could say just use deep learning models, don't use any linear regression or whatever. Yeah.
Okay, sounds very cool. And we also just received the message that Opera is not compatible with Azure ML. Neither is Netscape, by the way. So.
Well, that's good to know. Okay.
Okay. All right. Thank you, guys. I've learned a lot, and I hope the audience has learned a lot as well. You can always, I guess, contact us if you have any more specific questions on this, or in the YouTube chats. We'll answer them. And for the rest, there's nothing left to me than thank you to be there. Also, next Rootlabs session is, I think, next week already. So we're following up quickly. It will be on Metabase and LakeFS. It will be the first Tour de Tools. It's actually on 2 weeks Monday, 8th of March. We have Tour de Tools with Bart and Gauthier, and they will show us Metabase and LakeFS. Thank you, everyone, and see you next time.
See you. Thank you. Bye-bye.